I know the opponents are mad. All right, we got about 10 minutes. I'm watching the clock. I'm gonna try to squeeze a match in there. I don't know. We're gonna give it a go. Come on. Let's go. Let's go. Let's go to mode.
You're gonna be the talk of all the fishermen.
Let's go brawl. I really don't have enough time, but I probably just have to quit it early. It'll be okay. Good. I don't like that one of these guys. Let's switch off Rock. I don't want him either. Switch him. Hey, I could switch over here. Man, they just keep giving me people I do not want to use. I'd rather use him. Or Amon. I can go Amon. And let me switch these guys. If somebody wants Marcus. Right. I don't really know what he needs.
It is better to be feared.
If he uses mana. If he uses mana, I have to give him mana boots. I got like 5 minutes. You got Petrified, that's dangerous. They got a lot of healing. Aurora with Eudora. At least I don't have a marksman. We got a marksman. We don't have a tank. I probably should have gone tank. We got 2 marksmen. A couple of assassins. Let's go with mana boots. Did he need mana? Yeah, he was doing that. Yeah, I think just want the rest of the rock and roll.
5 seconds till the enemy reaches the battlefield. Smash them. All troops deployed. First blood.
I'm dead. Oh, they got their people like hiding in the bushes. We don't have no wallers like that. I should have took notice. I don't really know how to use it.
Out of evil deeds,
all right.
it's a greater good.
All right, it's a long. You're my guy. Ultimate 3D and 20 yards. Ooh. We don't have a front line. We're gonna lose the time. They just fought in the bush. They see my team sees you going over there and they don't even make a motion.
I've never told him this, but I do see a bright future in Goshen.
Couldn't give me a split second to get into position. There, stop. Like, my team is so far back. Like, bro, y'all can't beat that far back.
On the battlefield, noble blood won't give you a second life.
Where are these marksmen?
Above the rest, that's where we Paxley's deserve.
He's trying to pick me off. I'm gonna go near that bush. He's always lurking in the bush. Put it in safety. Yeah, he can heal when he's doing invisible. I need to make use of that. Is it? I got 3 minutes. 3 minutos más. Ah. 6. Oh. I had to run for her. I knew she was coming for me. I was like, nope, not today. Not today. I knew it. Ah, run. No, marksman, you don't see them right there. Like, what? You need to target them. You're the only one who's like continuous damage. There we go. So at least somebody. Goes a long go. Oh, that's it. Let's be. Go. Ah, got right. Oh, she got me with the lightning. What time is it? I got those minutos más. Come on, guys. We gotta finish this. Let's go. This is what's called a brawl, man. It's one lane, just free for all. It's a brawl. Hit her. Somebody hit her. Come on, y'all are marksmen. Somebody should be able to hit her. Run. Ooh. All right. I have no tolerance. 20 seconds on the ultimate. Oh my goodness, get over my person. Here. Ooh. This Eudora is always lurking in the bushes. He's so peaceful.
Paxleys are always true to their roots.
I need my team. Like, where are these guys? I'm coming, guys. Let me see the time. I got a full minute. Maybe not a full minute.
Color my judgment.
Yeah. Where are these marksmen going? Like, what is taking the call? It goes along. I got 9 seconds left. I'm about to go. I don't have my flicker.
Out of evil deeds.
I gotta go, guys. I'm about to get out here. Are you trying to say a lot too much? That time. Gotta go. I'm gonna go for one more push. Get one more push out of him.
I have no tolerance.
Like, there's a reason we're not attacking, like, stuff in the ring. Y'all just taking y'all sweet time. Y'all got unlimited damage and y'all just taking your time. I'm like, bruh. Like, we're trying to attack, but y'all are just being extra slow. Zhuang is the only one that's like kind of getting to me. I'm coming, guys. I see this time.
People regard me.
It's gonna be my last push. Win, lose, or draw. I can get at least 3 more. Oh, see, that would have been nice. All right, she got me. All right, I'm good. No. It's Eudora. That's what she does. She like freezes you. You can't, you know. But now the rest of my team can attack her. Nobody. Here we go. Hey, let's take her Eudora. And she's low, so she's not gonna be able to heal. This is their chance. It's like now or never, guys. Go ahead, just attack her. Shoot her. Shoot her. Shoot them. Just stay together. Keep alternating. There you go. I'm coming, guys. I'm coming. I see the time. We're about to get started. I know I said the last one was the last push, but we're like so close. We're almost done. We got 2 more turrets, but I'm not gonna stay for all of them. I'm about to leave. And we'll get started. Come on. Trying to push a little bit hard. She got me. She got me. All right. She's dead anyway. All right, I gotta go. Bye-bye. All right, all right. I think we're good there. All right, all right. Okay, not bad. A minute and about 2 minutes. That's not too terribly bad. I've done much worse. I had to abandon them, but it's a brawl. It's designed to be 10 minutes. I left maybe a minute or two early, but they had the advantage, so they're gonna have to work that out. Okay. All right. So, welcome, gentlemen. Hey, give me just a moment. Ugh. Okay. So, as I was kind of getting ready for class, aside from that little gaming that you saw me do, I was looking to see. We only have 2 more sections of new material remaining. I think today we're going to be working on section 2.5. Let me see. Come on, why are you not working? I mean, not 2.5, 4.5. Where's my? Let's go with this. Yeah, section 4.5, right? So the last of the new material is section 4.6. I might do a bonus lecture of 4.7 or 4.8. You're not going to be responsible for those, but I might just do them just to kind of, because we got a little bit of extra time. We're ahead by like 1 lecture, so we got a little bit more time to review. If you have questions, feel free to either unmute yourself or type in the chat or the Q&A, and I will make sure to get your inquiries addressed. Give me just a moment. I'm going to log in. Sure. Let's go to Zoom. Ho, ho, ho. Join. This one right here. Don't connect, turn off, and join. Okay. Now, I want to say, and I really don't think that this applies to anybody here right now, because most of the people that show up routinely, so I have the least amount of issues with you guys. Really no issues, to be honest. But I think like last week about this time, maybe tomorrow, or last week on Thursday, I sent out an email for like anybody that had about 5 or more unexcused absences. So I sent out an email like, hey, do you intend to stay? So I'll probably be sitting down to go through that, looking for that information within the next 48 hours. So I'll just try to reach out to those students one more time. If I can't connect with them, then I'm going to submit their name to be purged. They may or may not purge. If the student gets purged, then they may or may not be able to get back in the course. So I don't know. But this is a long way to come. We're pretty much at the end, right? So if you think you're in that category of like 5 or more unexcused absences and you do intend to finish, send me an email and text me. Text me is the best way to get my attention. To my office phone number, just text me. And that way I'll make sure that you're not on that list. And also, if you are on that list, you would receive the email last Thursday. Okay. I don't really think this applies to most of you guys here, but and you can kind of check your attendance in Blackboard. I'm aware of like the sports people. I know there's like just different sports people, so I get those emails. I'm not gonna we're not gonna let attendance be an issue there. Just make sure to do what you need to do. Are there any questions? You guys have any questions? Okay, again, if you have questions, feel free to put it in the chat or unmute yourself to get my attention and we can talk about it. Yeah, so let's just kind of go ahead and get into today's material. And these cryptos and stocks, they just go up and down, up and down. That's all that they do. Oh, it's up. Oh, it's down. Oh, it's up. And it's all based on like the overall mood of like America or like whatever's going on in the news. And Trump, he just seems like he just be doing stuff to intentionally influence the stock market. And then these politicians, it's like legalized insider trading somehow, because they write regulations and so they know that like, okay, well, we're deregulating this. So they just use that information to do trades. I'm like, man, it's crazy. It's crazy. And it's like they just be cleaning the house because it's pretty much insider trading, but somehow they're able to do it legally. So anyway, I'm just saying that because I got notifications on my phone. Y'all can ignore that. That's neither here nor there. Okay. So let's see. Okay. So we've been kind of going through integration, right? So we've gone through like the core of like integration techniques, like the power rule, like when you integrate a power, you add 1 to the power and you divide by the new power. We talked about the special case when we take the integral of x to the power of -1 ends up being the natural log of x. Maybe a few others, right? So here today and Monday, we're going to explore two more integration techniques, and today we're going to explore one called substitution. Okay, so a few objectives: we want to evaluate integrals using substitution, and then solve applied problems involving integration by substitution. Okay. So integration technique by substitution. The following formulas provide a basis for an integration technique called substitution. The integral of u to the power of r du, that's kind of like the integral of a power. You still add 1 to the power divided by the new power plus a constant, where u is like some function, right? U might be some function or whatever. Okay. And the main thing here with the integration by substitution, in your integrand, you have to have u, which is your function, with du adjacent to whatever the derivative of u is adjacent to, right? And we'll work a few examples so you can catch the nuances. It's a little bit different. It's like an application or an extension of the techniques that we were doing before. It's a little bit different. The main takeaway here is in your integrand, you're looking for these forms on the left along with the derivative of whatever your u is, right? That's the trick. But again, it don't really sink in until you work a few examples. Okay, the integral of du over u is the natural log of absolute value of u plus c, or just the natural log of u plus c whenever u is positive. Unless noted otherwise, we assume that u is positive. Okay, let's give this one a go. So for y equals to f of x equals to x cubed, find dy. I think that's just finding the derivative. I think I'm just going to skip this, all right? Yeah, just take the derivative. It should be 3x squared dx, all right? So the derivative will be 3x squared dx. Let me actually write some stuff here because this one's a little bit, just a little. Ooh. Okay. Man, I'm still out of shape. I've been going to these workout groups trying to, get my cardio back a little bit. Man, they be whooping my butt, man. Whew. It'd be good though. But I've noticed that as long as I'm consistent in going, I'm getting stronger and stronger. It's getting easier and easier for me to go further and further. So I'm excited about that. Okay. Now, this didn't ask us to find dy by dx. This asks us to find dy, right? And so we can essentially still take the derivative, but there is a nuance, right? So let's, there are two ways we could go about this. What I'm going to do, whenever I take the derivative of something, I'm going to do the way I like to do it. The book might do it a little bit different. Yeah. Like this. I think you're okay. There are a couple of ways to go about this, but I'm just going to showcase the way I like to do it. So whenever I take the derivative of something, like if I take the derivative of y, I'm going to put dy. If I take the derivative of x, I'm going to put dx. Okay, that's the main takeaway. The book might do something like whenever you take the derivative of y, you put dy by dx. You take the derivative like normal, then you move your dx to the other side. You can isolate dy like algebra. So that's two different ways of saying the same thing. Again, I'm going to showcase the way that I like to do it, which is whenever I take the derivative, I'm going to put d of whatever that variable is, right? So if you start with y equals x cubed, and I take the derivative of both sides with respect to x, or just take the derivative. So my y is going to become dy. The derivative of x cubed is going to be 3x squared dx. So then normally we would write this as dy by dx. You can do that, but then you need to use algebra to move that dx to the other side, the differential with respect to x, or differential x or whatever. So that's pretty much what we were looking for. Okay. So this is a little bit different than what we've been doing in the past, but we just got to adjust here. Okay. So I think the way the book did it, they just took the derivative like normal. They put dy by dx, they got their result, and then they isolated the differential of y, the dy, and moved the dx to the other side using algebra, right? So Whichever one you resonate more with, the way I did it or the way the book did it. Both are viable. Okay, now this one asks us to find du. Okay, so we're starting with u equals x to the power of 2/3. Right, I could put du by dx. I'm more of a fan of whenever I take the derivative of a variable, I'm going to put d of that variable. So on the left, I'm going to have du. On the right, I'm going to take the derivative. That means the 2/3 comes down. Subtract 1 is going to be to the power of a negative 1/3 dx. You could write it. You could write it as 2 dx over 3 times the cube root of x. I'm just going to leave it like this for the sake of simplicity. The other is like, it's just the syntax. What form do they want it in? I'm going to stop here though. Yeah, that's what it is. Okay. Now notice the way the book did it. They to find du, they just took the derivative like normal. Du, the derivative of u with respect to x. They got their answer, and then they isolated the du through algebra. So they multiplied both sides by dx, and they got the same thing that we got. Okay, find dy. Same thing here. So we're starting with y equals e to the power of x squared. Okay. So on the left, when we take the derivative, we're going to have dy. The derivative of e is itself times what? The derivative of the power, which is going to be 2x dx. I think that's it. Yeah. So our dy is going to take on. Okay. 2x e to the 2x dx. 2x e to the, that should be x squared, right? I think that's a typo. This is supposed to say e to the x squared. Okay. All right. So now our first showcase of integration technique by substitution, right? Okay, so the thing with substitution, you choose a potential u, and then you need to also identify your du, right? So one potential u, we could do something like, okay, let's try let u equal x cubed plus 1. If this is our u, then that means our du is going to be what? 3x squared dx. Is there a 3x squared dx? 3x squared dx. Yes. Okay. So now we're going to apply the substitution to the original integral, right? Because if we try to integrate it directly, it just gets nasty and we're not going to be able to do it. But using this technique of substitution, we can put it into a form that we can manipulate. Let's go ahead and make this substitution. So now this is gonna become the integral of u to the power of 10 du. So that original integral that we had, again, if we tried to integrate that directly, we're not gonna be able to do it. But now through substitution, we transform it into a form that we can integrate this guy. We can integrate this, right? So this becomes, now we just apply the power rule. It should become what? U to the power 11 over 11 plus some constant. All right. So then now we back substitute. Whatever our U is, we put it back. But the trick is, again, the trick was before we get it, to get it into the proper form, this du we identified in purple here, right? You can see it here. That's the trick. You got to have that du there, the proper du. Then you can do the substitution. That's the most challenging part, in my opinion, is getting that part correct. So then now we back substitute our u. So we're going to have x cubed plus 1 to the power of 11 over 11 plus some constant. Okay. And then you should be able to check by taking the derivative. All right, the 11 will come down. Let's see. The 11 will come down to cancel. That becomes a 10. The constant is gone. And then we got to say times the derivative of the inside function. So times the 3x squared dx. Yeah, we're good. Okay. We're already halfway through this section for today.
No, this is my
Yeah, you good. Okay. Post in the meeting. Okay, let's keep going. So we got x cubed plus 1 to the 11 over 11 plus c. X cubed plus 1 to the 11 over 11 plus c. All right? So notice they identified their u and their du, did the substitution, took the integral, and then back substituted. Okay. Let's try another one. Quick check. Maybe I might come back since we're kind of going through this quickly. I might come back and do these quick checks for some more additional practice. Evaluate. Okay, so let's see if we can do substitution. All right, let's just see. So first we might try something like let u equal, what is it, 1 plus x squared? Okay, if that's our u, then our du is going to become what? 2x dx. You see the 2x dx at the top. So this is a good candidate, right? So now if we do our substitution, it looks like we have what? Du over u. And that's what? Natural log? Natural log of u plus some constant. So that's going to become the natural log of 1 plus x squared. Yeah. Plus some constant. For whatever reason, in my psyche, I just fly across my mind. I was like, I wonder if we won that match. We had the advantage. I tried to get them out their head, because I already knew I was going to have to leave early because I started kind of late. I need at least 10 minutes for those type of matches, and I only had like maybe 9 or 8 minutes. So I was like, I'm gonna have to leave them early. So, I mean, I don't know. I can check later. All right. Let me center this. There's no need for that to be all the way over there. Okay. So again, we got the, and again, if we wanted to check, we would take the derivative. The derivative of natural log is du over u. So that would be 2x over 1 plus x squared dx. The constant is gone. Looks like we're good. Okay. Natural log of 1 plus x squared plus c. Okay. Let's try another one. Let's see. Okay. So we might let u be, let's try 1 plus x squared. So that means our du is 2x dx. Okay. So now when we do our substitution, that's going to be what? Du over u squared. Right? So then, if we, because that's really u to the minus 2. So then we should be able to add 1. So it should become u to the minus 1 over minus 1 plus some constant. Okay, so our u is 1 plus x squared. So negative, we got this 1 plus x squared plus a constant. So negative 1 over 1 plus x squared Minus 1 will come down. Double negative is positive. It becomes a minus 2 times 2x dx. Constant is gone. It looks good, right? So again, whenever with integration, whenever you get your answer, if you're doubting it, the way you check is by taking the derivative, right? And so hopefully at this point, we're like masters of taking the derivative. So, negative 1 over 1 plus x squared plus a constant. All right. Okay, I'll probably come back and do these quick checks. Oh, we got another one. We got a couple, maybe one or two more. All right, let's see if we can figure out what our u is here. Du over u. Okay. So at first glance, I was tempted to make my u maybe 3x. And it doesn't really feel like that's going anywhere if I let u be 3x, right? It just doesn't seem like it's working. So then I was like, okay, let's try a different u. Let's try letting u be the natural log of 3x and see what happens, all right? Let's just follow that track. So we're going to let u be the natural log of 3x. So that means our du, the derivative of natural log is du over u. So that would be 3 over 3x dx, which boils down to dx over x, which is exactly what we wanted, right? So if that's our u and our du, so now if we do our substitution, natural log of 3x is u, dx over x is du. We're taking the integral of this guy with that substitution. So then the integral of u is going to become what? U squared over 2 plus some constant. And then we back substitute. It's going to be the natural log of 3x quantity squared over 2 plus a constant. Again, when in doubt, take the derivative to check your work. I know I make it seem, I don't know if I make it seem easier or not. I feel like I do in this instance. It just, this whole thing of the substitution technique, it just takes exposure and awareness. Like if you try to evaluate some of these integrals and you don't have the wherewithal to think, oh well, let me try the substitution. Let me see if I can do the substitution method. If you don't have that in your bag of tricks, then without the substitution method, a lot of these you can't do. And then we got another technique on Monday called integration by parts. That's another one. It's similar to this, just a little bit different. It's like the next step or the next, I don't know, level or whatever. All right. Let's see. That comes down, times the derivative of the inside function would be 3 over 3x. So that's gone. Just dx over x. Oh, yeah, that's right. Okay. So we got the natural log of 3x quantity squared over 2 plus c. Natural log of 3x quantity squared over 2 plus c. What's the time? Well, sorry, guys. Okay, we got 10 slides remaining. Let's keep going. Okay. Okay, let's just try it. So when I first glance at it, what comes to my mind, let's try this. Let me think. Actually, I was about to let u be e to the x squared, but I think I want to backtrack. Let's try this one instead. Let's see. Let u equal x squared. Let's just try x squared and see what happens. Now, if that's our u, then our du is going to be what? 2x dx, right? We got the x dx, but there's an extra 2 in there. So we need to move that 2 to the other side. We're going to divide both sides by 2. So we say half du equals x dx. Okay, we got the x dx. We got e to the power of u. I think we're ready to substitute. Okay. So again, it's going to be e to the power of u, or x dx. So and then half du. All right. So the trick there, when we found our du, we had that extra constant, the extra 2 in there. We can divide both sides by 2 and move it to the other side. So half of du gives us our x dx, and then we make the substitution like this. E to the u, half of du. Now we're ready to integrate. Okay. Now the half just pretty much goes in front. The integral of u is itself. Let's see. If we had 1/2 e to the u, let me see if I feel like I'm missing something. Let's see. Let me just take the derivative real quick. So the derivative of e is itself times du. That's gone, right? Times du. I think this is okay. Then we just back substitute. So then 1/2, our u is x squared plus some constant. Let me check one more time. Again, we check this by taking the derivative. The derivative of e is itself, right? Times the derivative of the power, which is going to be times the 2x. The 2.5 are going to cancel. We're going to be left with x e to the x squared, and the constant is gone, or dx is there. So I'm confident in this. Let's see what the book did. 1/2 e to the x squared plus c. Dang. Oh, we only got like one more section, so I ain't gonna talk about it. All right. Was that the last one? Quick check. Oh, nope. They keep sneaking these in here. Okay. All right. Let's see if we can find our u and our du here. Okay. So at first glance, I feel, let me see, let u be x plus 3. So that means our du would be what? Just dx. Okay. So then if we do the substitution, it looks like we're going to have du over u. All right, with that substitution. And that integral is kind of a special case. Natural log of u plus some constant. So then it should be what? The natural log of x plus 3 plus a constant. And check by taking the derivative. If you're just joining us, we're doing the this is called the substitution method. So you know how to access the recordings, right? So you're gonna have to go back, and we'll try to get as many examples in. We still got a good amount of time, like 45 minutes, give or take.
Excuse me, Professor. I was able to join by 6:15. Was the attendance cut off by then?
No, you're good. Don't worry about it. Yeah.
All right.
Like if it was cut off, you wouldn't be. You wouldn't.
Oh, okay.
No, you're good. Don't worry about it. I know. Just you're good. Yeah. No, I mean we're pretty much at the end of the semester. I just don't worry about that. Just be here and don't worry about it. Okay. I just be acting like a little bitch sometimes. It's annoying. I notice it, but it's really not that big a deal. It's just, I just notice it, but I just try to shake it off and keep moving. Because if I harp on it, then I'll get irritated. If I get irritated, then I'll start like slashing, and I just don't want to do that. So don't worry about it. Okay. Yeah, I think this is good, right? So the derivative of natural log is du over u. So that would be dx over x plus 3. All right, I think we're good. This looks good. Okay, we got that one. How many more? Example 10. Let's knock it out. All right. Let's see. Can we find our u? Let's see. So let u be, oh, this one's trippy. Okay. So let u be x squared plus 3. If that's our u, then our corresponding du would be what? 2x dx. But they have 5x dx. All right? So in order for that, let me see. If we divide both sides by 2, and what? I guess we have to multiply both sides by 5 halves. Okay? Multiply both sides by 5 halves. So I'll capture that in the following way. Because just to get the coefficients correct, right? So I'm going to say this times 5 halves and this times 5 halves, right? If I do this, the 2's are gone, and I think we get it into the form that we need, right? So 5 halves of du equals 5x dx. 5x dx. All right, so we had to multiply both sides by the proper constant, right, for it to work out. Okay, now that we have the necessary components, now we're ready to substitute. Okay. So we're going to take what? We got the square root of u. 5 halves of du. I'm going to put I'll go like this. I'm just trying to be clear that this du is outside the radical. And we're taking the integral. Okay, I think those are the necessary components. Oh, and as x goes from 0 to 1. Okay, so then u to the 1/2 becomes what? U to the 3/2 over 3/2. Okay, let's keep going over here. So the 5/2 just persists. 1/2 becomes 3/2. So u to the 3/2 over 3/2. Okay, plus some constant. And then let me see, if we flip and multiply, looks like the 2's are gone. It becomes 5/3. Oh, well, we don't need the plus c because we got a definite integral. So we're evaluating this as x goes from 0 to 1, right? Oh, wait. Before we do that, we need to back substitute before we do that. Because that the 0 and 1 refer to x, not u. All right, so right now I'm just going to put the plus c, but we're going to get rid of that in just a moment. Okay, so let's go ahead and back substitute. So we got what? 5/3. Our u is x squared plus 3 to the power of 3/2. And we want to evaluate this guy as x goes from 0 to 1. Okay. Now, when we plug in a 1, we get what? 5/3, 4 to the power of 3/2. I'll just kind of group it like that. When x is 0, 5/3 times 3 to the power of 3/2. Square root of 4 is 2 to the power of 3 is 8. I might have enough space over here. So 2 to 8 times 5 is 40. So that first one looks like it's 40 over 3 minus. Let's see. Now it's 3 times 3 times 3. So 3 times the square root of 3. So those 3's are going to cancel. Looks like it's 5 times the square root of 3. This will be my exact result, and then we'll probably use a calculator to get an approximation. 40 over 3 minus 5 root 3. Okay, let me crunch that number to see if it matches up. So let's do 40 over 3 minus 5 times the square root of 3. Okay. I think that's right. We get approximately, let me kind of get rid of this for right now. 4.6731. $67.31. 4.6731. Let's see, how do we do? Let's get rid of this. 6731 looks good. That was an adventure. Let's recap that one real quick. So we did integration by parts, right? We said we were like, okay, well, let u be this x squared plus 3. So if that's our u, our du was what? 2x dx. But we needed 5x dx. So in order to convert from both sides by 5 halves, that way the 2 would cancel and we'd be left with the 5. So now square root of u du times 5 halves as x goes from 0 to 1. Now actually, that 0 to 1 is supposed to be for x. When we have it next to u like that, so when x is 0, that really should be, if I want to have the proper form, if I'm doing it in terms of u, when x is 0, u is 3. When x is 1, u is 4. Right? That would be proper for that. But, you know, remember, I came back and substituted. I did my back substitution, put it back in terms of x. Then I just integrated as x went from 0 to 1. Right? Let me see. I think that's proper. Let's look at the book real quick on that note, if I can get this to work. Do. Oh, they didn't even write it. They didn't even bother writing it, and they just evaluated at the end. But notice they did put the 0 to 1 once they back substituted. And we got it. Okay, what's the time? We still got like 35 minutes. I think I will go back and do some of those quick checks. I'll come back to this a little bit. I don't want to work backwards. Not really. This is actually, what is this one? Oh, yeah, that was interesting. I'm sorry, I'm just being distracted. A little bit of ADD. Let me kind of go back. I'm going to start from the beginning and capture some of those quick checks. Man, I'm struggling today. Let me see. I'll just start here. Example 1. So like this, 2, blah, blah, blah. Quick check 1. Oh, this is a lot. I'm not going to do all of these. Find the differentials. Actually, I think I'm going to skip these. These weren't too terribly bad because when we're doing integration by parts, this concept comes out naturally. So I'm going to skip this quick check. Quick check 2. We got the solution. Okay, so what I'm going to do, I'm going to duplicate this slide and get rid of the excess work because I don't really want, I want to just practice. Duplicate. And then here, let's go like this. Copy and paste. Evaluate. I'll get rid of all of this stuff. I need to crop. Okay. All right, I think we can work with that. Oh, let's try that again. Crop. Okay, where's my option? It's always something. All right, that's good. Okay. All right, so let's give this one a go. Evaluate. So we're gonna try our hand more substitution, right? Okay. So we're gonna say something like let u equal. Let me get rid of this. Let's try 2x squared plus 3, if that's our u. So then our du would be what? 4x dx. Okay, we got the 4x dx. You can see it here, highlighted in purple. Okay, so let's make this substitution. This is going to be the integral. What is that? U cubed du. Okay, that's not too terribly bad. That should be what? U to the 4 over 4 plus some constant, and then we back substitute. So that's going to be the 2x squared plus 3 to the power of 4 over 4 plus some constant. When in doubt, take your derivative, right? If you wanted to check, just take the derivative. Like if it was a testing environment or whatever. All right. 2x squared plus 3 to the power of 4 over 4 plus c. 2x squared plus 3 to the power of 4 over 4 plus c. Okay, that wasn't too bad. That was quick check 2. So I'm going to have to do that little maneuver again. Okay, so let me duplicate this slide. What's the time? Let's duplicate this one. This, like that. Copy and paste. There's good. Crop. Check. All right. Evaluate. All right, let's see if we can find this u. All right, so then let u equal 3 plus 2x cubed. So if that's the proper u, then our du is going to be 6x squared dx. Okay, so that's a good omen. We see it right there with those two pieces, this guy and that guy. So this is promising. Let me see. So we have what? The square root of u. There's a du here, the integral. So that's really what? U to the power of a negative 1/2. So if we add one, yeah. So then if we add one, it's going to be what? U to the power of a 1/2 divided by a 1/2, or times 2, plus some constant. So now if we take the derivative, the 1/2 comes down, it's canceled. We have our negative 1/2. I think everything kind of works out, all right? So now we back substitute. So it's going to be 2 times the square root. Our u is 3 plus 2x cubed, 3 plus 2x cubed, plus some constant. I feel like there should be questions, but I acknowledge, you know how we've kind of been doing all this time. So I can't force you to ask questions. All I can do is show you the door. You must decide to open it and walk through it. I can only show you the door. I can't make you knock. He is the one. So I don't know. I guess they're coming out with the Matrix 5. It's like it has potential. I was not feeling Matrix 4. Like it had potential. It's just like the way they did it was just like it just felt so cringy to me. But it's like I understood the concept though. I thought the concept was fantastic, but I think the execution was just off. It was just off. And I don't know what they need to do to fix it. And like the whole thing with Morpheus, I was like, oh, I'm not feeling this. They got the younger guy. I just was not feeling it at all. But I did like the concepts. Like it had potential for like I could see a TV series coming out of it. And it's like, you know, the whole franchise apparently was stolen from this from a black woman, right? Where she and apparently the Matrix is supposed to be the sequel. No, the Matrix is supposed to be the prequel to Terminator. So is I think like the Matrix happens first. What's the order? Because Neo is Sean is Neo and the woman, but it's basically the same universe. The Matrix and the Terminator. I think the Terminator came first though, because I think Neo is the son of the woman. I can't think of her name, Connor or whatever. And so you had the Terminator and all that stuff happened, and then humans are enslaved, and that's the result. So there's a lot of potential, but I'd rather them link up with the original creator, give her credit, pay her, and then collaborate with her. Like, stop trying to steal everything. Stop trying to appropriate. You know, like work with her and like let her do it. And y'all can everybody can eat. There's no need to be selfish or greedy. Like, make sure everybody's eating. Anyway, let's keep going. Right. So we got 2 times the square root of 3 plus 2x cubed. 2 looks good, right? Anyway. Okay, let's keep going. What else we got? We did quick check 3. Yeah, let's do this one. Duplicate. Now, sometimes, like in my flights of fancy, I think about, I was like, well, like using AI to just, I was like, okay, for instance, get AI to write a makeup, like to make up a script for like the Matrix 5 and then read through it and then have it make alterations and changes. And then once it writes the script, have it go ahead and make like clips and make the whole movie, right? Because AI is nothing it can't do, right? You just give it the prompt and turn it loose to see what it does. Just to play around, because like, you know, there are movies and like franchises that like they just got cut short. Like another one was this show called Heroes. All right. I think we're back. Let me, yep, I can see my audio. Let me share my screen. See, they heard me talking about the Matrix and trying to put things right. They had to silence it. They try to silence me. The agents are onto us. We must be brief. The line isn't secure. Oh man. Let me join. That's so creepy. Because I was really just playing. I just thought it was interesting things. And then it disconnects my feed. But this is actually a really exciting time to be alive because it's just like stay as a participant. There's nothing you can't do. Like for the longest, I had all these ideas for like stories and writing, but I was not really a strong writer and I was nervous. But now you can just load the prompt into the AI. It'll do the main structure, and then you can take it and like revise it. Make it, just revise it. You can either let the AI revise it, or you can go through it manually. But it'll give you like the main structure for whatever ideas or whatever creative or whatever questions you have. And like some of the questions that people ask are just like really thought provoking. I'm like, yo, this stuff is wild. Like it's really interesting. So, anywho, there's nothing you can't do in this day and age. You just gotta have that curious mind and like go after it, like on the real. Okay. So again, we're back. We have our x squared dx, but we have an extra 12 in there. So to account for that, what we're going to do is divide both sides by 12. And so that means we're going to have what? 1 over 12 du equals x squared dx. Now we have the proper form. Here's our x squared dx, right? I think we're ready for our substitution now. So, okay, so it should be what? E to the power of u, 1 over 12 du, and I think that's it, right? I don't know if I'm opening up the floodgates. We got about, I don't want to keep you more than about 10 minutes, maybe no more than about 10 minutes or so. I don't know if this question is going to open floodgates or not, but like, why was everybody hating on Snow White so much? Like, why were they, what happened? I know something happened there. I didn't like dig too deep in it. I did see it, but I'm like, it's a kids movie. I'm like, you know what I mean? I don't know. It was, and then I saw like something that was talking about it. I was like, it was. They made good points, but I'm like, it's a kids movie. What did you expect? Like it to be Marvel's Endgame? Level. It's not that level. It's like something real light. Anyway, I don't know. I just thought it was strange. All right. I think we need to take the integral. All right. I think it's just okay. I think the integral is just going to be this guy. 1 over 12 e to the u plus some constant. Okay, let's back substitute and do a quick check. So 1 over 12 e to the power of 4x cubed. It feels like we're missing something, but I'm gonna go with it for now. Plus some constant. So before I check what the book did, I'm just gonna try to take the derivative and see if it works out, right? So the derivative of e is itself times the derivative of the power is going to be what? 12x squared. The 12 and the 1 over 12 are going to cancel. So we're just going to be left with just the x squared dx, and the constant is gone. And I think it seems like it worked out. So I feel good about this. Now, again, we got 1 over 12 e to the blah, blah, blah. Yeah, you see it there. Another random thing, like, what is it? On Disney Plus, they came out with Mufasa and Moana 2. So those are fun if you haven't seen them. All right, let's keep going. No more than 10 minutes. I'm watching the clock. And I think we did all the quick checks. That might be the last one. What's the time? Did we get that one? Yeah, we got that one. I do kind of want to, I don't want to like squander this 10 minutes. A little bit more slides. Yeah, this ain't really be on the fritz. Okay. Let me duplicate this. Just for a few minutes. I'll do a few questions from the homework. Go full screen. This one, yeah, it's okay. We're close enough. The time is going to be up. Are there any burning questions? Let me just think of some closing announcements real quick. All right, so there's only one more official section of new content, right? So today, again, we worked on section 4.5. So that means that Monday's lecture is going to be the last of the new material that you're responsible for. On Monday we're going to be working on this section 4.6. It should be integration by parts. That's an interesting example. That's an interesting section. Maybe I might do like one or two additional sections, but you're not going to be responsible. Like if I do 4.7 and or if there's a 4.8, it's just a bonus lecture. You're not going to be responsible for those. But then after next week, we'll pretty much be taking. I'll see how many days we have left as far as our sessions. More than likely, we'll be doing like reviewing one chapter a day. Matter of fact, let me go ahead and pull up the calendar real quick. So today is the 2nd. Next week we can fill all those days. So the last day of class I think might be April 30th. Let me see. 1, 2, 3, 4, 5, 6. It seems like we got an extra. Oh, we do have exam 2, and we should probably okay. So we'll do that week. Probably the 14th and 16th we will review exam 2. And I think the last day of class is April 30th. That'll leave us 4 days. And so those 4 days, the 21st, 23rd, 28th, and 30th, we'll basically review a chapter a day. And that should get us to the end. So 1 week we'll review for exam 2. And then those last 4 sessions, we'll review a chapter a day in preparation for the final. Let me think if there's anything else. Okay, I can't. Give me just a moment. Okay, I can't really think of anything else. All right, guys, we're in the home stretch again. We didn't come this far to just come this far. We came this far to go all the way. If there are any burning questions, we're going to go ahead and end the session here. And for one beautiful mind to another, have a great weekend, gentlemen. And we'll meet back on Monday, same time, same place for the final installment. Have a great weekend, guys. Take care.
Professor,
Mm-hmm.
this is Jabri, right? I was just letting you know that last week I know I missed 2 days, Tuesday and I'm sorry, Monday and Wednesday. I was on a cruise. I could have emailed you. I should have let you know sooner, but yeah.
An email and send me a text message, and I'll try to update.
A text message.
Yeah, my office phone is.
All right.
Yeah, just send me a text, an email and a text. The text is just to get my attention and remind me. Email is just for records. Email, I might miss it. So, but we need it on file. Just something to remind me. And then the text.
Okay. And your phone number is on the banner web, or I'm sorry, Blackboard.
It is on Blackboard. It's like on the syllabus. It's in several locations. Yeah.
All right. Thank you.
Send like in all my emails at the bottom. You can find it there.
Okay. Thank you.
Anybody else going once, going twice? Forever hold your peas and rice. All right, guys. Have a great weekend. All right, let me go ahead and do this.